Hey, algebra students. In this lesson, we're going to be talking about how you can solve systems of linear equations by substitution. Now, let me just explain what we're talking about here because that was a mouthful and there's a lot of words in there we need to make sure we know the answer, like have an understanding of. So, a system of equations. What are we talking about with a system of equations? Specifically, we're going to be talking about two different equations in this lesson. Linear equations means that you can graph the equations and they show up as a line on the graph. And what does the line actually show? It shows you every single xy coordinate point that x and that y is a solution to the equation. So we're going to be dealing with equations that are two separate lines on a graph. And as long as those two equations are lines that intersect one another, there's going to be one particular point, that point where those two lines intersect, where the same xy coordinate pair solves both equations. And that is the solution to a system of linear equations, the point at which the two lines intersect, because that xy pair, if we plug in that x and that y to one equation, it'll be a good solution. We plug it into the other equation, it's a good solution. Now remember, the line itself is showing you a solution for that one equation. So both lines are an infinite number of xy coordinates that solve that equation, but there's just one coordinate where they intersect each other that solves both equations at the same time. All right, we're going to learn how to solve these equations by substitution. There's a 5-step process for this. First of all, we're going to rearrange one of the equations so it's in the form y equals mx plus b or x equals my plus b. This first one's familiar to us. This is slope-intercept form. The second form isn't really a form. It just gets x on a side by itself. Y equals mx plus b is my favorite way to do this because it is slope-intercept form. We're used to seeing things this way. Number 2, we substitute the expression for the variable from the first step into the second equation. So if we know that y equals mx plus b, we're going to plug mx plus b in instead of y anytime y appears in the equation. Well, that's going to do for us, it's going to make it so we only have x's in our equations. We don't have y's anymore. We could solve for what x is. Next, we're going to solve the resulting equation. We're going to substitute the value of the variable that we find from our solution into one of the original equations. So if we were finding x by plugging in mx plus b for y, we were finding x. Now, once we find the value of x, we plug that back into the equation to find y. And then we're going to write the values of the unknowns as an ordered pair. Okay, now, again, this is one of those things I can talk about, and you're not really going to know what I mean until we actually do it. So let's do letter A. In letter A, we actually have two equations that are already written in slope-intercept form. Y equals 4x minus 3, y equals 3x minus 5. Hey, if y equals 4x minus 3 and y equals 3x minus 5, does it make sense that we could just plug in 4x minus 3 for y in the second equation? Because it's the same thing as y. So if y is 4x minus 3, then I'm just going to say 4x minus 3 equals 3x minus 5. Do you see what we did there? Something really important. Now we only have one variable in our expression, and we can solve for that variable. Let's see, I'm going to subtract 3x from both sides. That's going to give me x minus 3 equals negative 5. And then I'm going to add 3 to both sides to get x by itself. That gives me x equals negative 2. Now, am I done? I've got the value of x. Well, no. What I need to do is plug x into one of my equations and figure out what y is. So I'm going to choose the second equation because I like the one that multiplies x by a smaller number. I don't know. That's what I usually do. So in that equation, I get y equals 3 times x, but we know that x is negative 2 at the intersection point. So y equals 3 times negative 2 minus 5. Or y equals negative 6 minus 5, which is the same thing as negative 11. Y equals negative 11. And that means that my xy coordinate point is negative 2, negative 11. Bam, there we have it. We just solved this first system of equations. Let's make sure that we're right here. There it is. Another way to make sure I'm right is to plug this in for x and y into our equation. If I plug in negative 2 for x, that's my x coordinate. 4 times negative 2 is negative 8. Minus 3 is negative 11. Check. 3 times negative 2 is negative 6. Minus 5 is negative 11. Check. All right, I've solved that system of equations successfully. Let's go on to letter B. In this one, I noticed that my equation, my first equation, has x on a side by itself. Wonder if we could use that. What if, instead of x in the second equation, I plug in 3y minus 11? I'm just going to write this out like this. So 5 times, instead of x, because x equals 3y minus 11, they're equivalent, I'm just going to plug in 5 times 3y minus 11 plus 2y. Okay, so I still have my plus 2y there, equals negative 4. First thing I'm going to do is distribute the 5. It's going to be 15y minus 55 plus 2x equals negative 4. Oh, hold on a second. I messed up. This is 2y. That should be 2y here and 2y here. There was no x. It's 2y. It was this term. Okay, let's go back to it. So now I have 15 plus 2y can be combined into 17y minus 55 equals negative 4. The next thing I'm going to do is add 55 to both sides. That's going to be 17y equals, let's see, negative 4 plus 55 is going to be positive 51. Well, that's convenient because if I divide 51 by 17, I get 3. Y equals 3. So now I know the y value. I need to go back and plug that y value in for y in one of my equations. I'm going to plug in 3 for y in this first equation. I get x equals 3 times 3 minus 11. Let's see, 3 times 3 is 9, so it's going to be 9 minus 11. That means that this is going to equal negative 2. 9 minus 11 is negative 2. So my solution to the system of equations is going to be negative 2 for x. I have to put that in my x coordinate spot, and 3 for y. Let's check. So negative 2 equals 3 times 3, which is 9, minus 11. Yeah, that makes sense. 3 times 3 minus 11 is negative 2. Let me check the second set. So 5 times negative 2 is negative 10. Plus 2 times 3 is 6. Negative 10 plus 6 is negative 4. It works for both of them. That is the correct solution. Let's go on to letter C. In letter C, I have these two equations. I notice that neither of them is in slope-intercept form. But I noticed that the second one is really easy to put into slope-intercept form. So that's what I'm going to do. I'm going to rewrite the second equation, y equals 2, let's see, negative 2x. I'm going to subtract 2x from both sides, plus 6. Notice I subtract 2x from both sides, I get y on a side by itself. So if y equals negative 2x plus 6, I can substitute that in to the first equation. I'm going to substitute in for y. Instead of y here, where it says 3y, I'm going to plug in negative 2x plus 6. And that puts everything in terms of x. So 4x plus 3 times negative 2x plus 6. And I can do that because it was 3 times y. And y is equal to negative 2x plus 6. That's going to equal 2. All right, now I'm going to distribute 4x plus minus 6x plus 18. I distributed the 3 to the negative 2, negative 6x. I distributed the 3 to the 6 to get 18. That's going to equal 2. Let's see, 4x minus 6x can be combined to make negative 2x plus 18 equals 2. I'm going to subtract 18 from both sides of this. I'm going to end up with negative 2x equals negative, let's see, 16. And then divide both sides by negative 2, I get x equals 8. Okay, so if x equals 8, I can figure out y pretty easily by plugging in x to the second equation. 2 times 8 is 16 plus y equals 6. Subtract 16 from both sides, I get y equals negative 10. So my ordered pair, the xy coordinate that solves both equations should be 8, negative 10. Let's just double check that works. 4 times 8 is 32. Minus 30, because plus 3 times negative 10 is going to be minus 30. So I get 32 minus 30 is 2. Check. Let's try the second one. 2 times 8 is 16. Minus 10, because we plus a negative 10, is 6. It solves both equations. Looks like I got this one right, too. Let's move on to letter D, the last of the non-word problems. This one is the hardest one of all, because notice that it's really hard to get any of these in slope-intercept form. I'm going to have some fractions here that I have to deal with. But you know what? So be it. I just have to deal with fractions. So I'm going to rewrite the first equation in slope-intercept form. First of all, it's going to be 3y, we subtract 4x from both sides, equals negative 4x plus 19. Now I'm going to divide everything by 3. Y equals, let's see, y equals negative 4 thirds x plus 19 over 3. Whew, this is going to be a doozy. So if I know that y equals that, what I'm going to do down below here, I'm going to plug y, I'm going to plug this expression in for y into the other equation. I need to use the other equation. Let's go like this, 7x minus 6 times negative 4 thirds x plus 19 over 3 equals negative 23, because it's just going to be this equation, except instead of y in this equation, I plugged in what I know y equals, negative 4 thirds x plus 19 over 3. All right, now I need to distribute. This is going to be a rough step. 6, okay, so negative 6 times negative 4 thirds. That's going to be negative 24 over, it's going to be, let's see, positive, because it's negative times negative, 24 over 3, which is actually going to be 8x. Okay, so 24 thirds is 8, and x is just going to multiply along. And then now for the really hard one, what's negative 6 times 19? Well, okay, so negative 6 times 19 is really close to negative 6 times 20. Negative 6 times 20 would have been 120, negative 120. But this is 6 less than that because it's only times 19. So it's going to be 114. And actually, it's going to be, again, it's negative 114 over 3 equals negative 23. Okay, so 114 over 3 can be simplified, I believe. Let's just see if we can divide 114 over 3, 38. So I'm going to change this. Instead of negative 114 over 3, we're going to put it as negative 38 minus 38. All right, I can combine like terms. 7x and 8x are like terms. It's going to be 15x minus 38 equals negative 23. Add 38 to both sides. 15x equals, hold on a second. 23 plus, negative 23 plus 38 is 15. That means that x equals 1. That's really easy, because if x equals 1, then I can go ahead and, let's see, I'm going to move this whole thing up. If x equals 1, I can go ahead and use the second equation, or the first. Let's do the first equation. It's going to be 4 times 1 plus 3y equals 19. 4 times 1 is just 4. I'm going to subtract 4 from both sides of this. That gives me 3y equals 15, or y equals 5. And then I can just go back up here and put my ordered pair, 1, comma, 5. Let's see if that works. 4 times 1 plus 3 times 5. 3 times 5 is 15. 15 plus 4 is 19. Check. And then I'm going to plug in 1, 5 here. 7 times 1 is 7. Minus 6 times 5, which is 30. 7 minus 30 is negative 23. I found the ordered pair that solves both equations.